Welcome to Hartman Math. This is lesson 5.6, Simplifying Radicals, part 1. Example number 1, simplify, adding square roots. And this applies to adding cube roots or fourth roots, it does not matter. You are not allowed to add the 50 and the 18. Cannot do it. You have to simplify first. We're only allowed to add like terms, in this case like radicals. Currently, they are not like radicals. You cannot add a root 50 to a root 18. We can simplify. We can break these down. Looking for perfect squares. 25 times 2, 9 times 2. So simplify first. We get 5 root 2 plus 3 root 2. So we're combining some root 2's with some more root 2's. We're going to get a collection of root 2's. How many root 2's do we get? Well, 5 of them here, 3 of them there. That's going to make 8 total root 2's. That's our final answer. We can combine when they're the same radical underneath. 8 root 2. Example number 2, simplify. Same thing. Cannot subtract. Say it's root 21. We can simplify. So break them down. 4 times 7. That one's prime, so we don't have to break that one down. So the square root of 4 is 2. Since it's outside, this is multiplication that's implied. 3 times 2 times root 7 minus, and if it helps, this is a 1 root 7. 6 root 7 minus 1 root 7 is 5 root 7. If we're combining root 7's, we're going to get root 7's. All right, go ahead and try this one. Pause the video here until you're ready. All right, we got 9 times 10 here, 4 times 5 here. I don't think we can do anything with that one. So if we simplify, we get 3 root 10 plus 2 root 5 minus 1 root 10. These two are like terms, so we can combine those. We'll just have to leave this one alone. 3 root 10 minus 1 root 10 is 2 root 10 plus the 2 root 5. That's as far as we can go because these are not like terms. They're not like radicals. Got to leave them separate. So as we're going to explore into some other roots and do some simplifying beyond what we know about square roots, we really need to be able to connect to the exponents to the powers. So pause the video here. Make sure you have all of these written down. Make sure they're handy. We're going to use them both for today and the next lesson as well. So make sure you're useful. These are the ones that you are responsible for knowing. Example number 3, simplify. So we're going to refer back to the chart. Since we're doing cube root, we want to be looking at the column of cubes. So like we were doing when we were talking about squares, we want to break this down where one of them is a perfect square, like a 9, a 25, a 49, like we've been working on. But this one is a cube root problem, so we want to break it down where one of our factors, the first factor, is a cube, like 8, 27, or 64, or 125, and so on. So what number in there evenly goes into the 250? Think about it for a moment. I think what we're looking for is 125. That's a cube. It's right here. We're looking at this side. We're not looking at this side. We're looking at this side. Later we'll see what the connection is. But right now we're looking at 125 as a cube. So let's break that down into cube root 125 times cube root 2. That's a perfect cube. According to our list, since 5 cubed is 125, the cube root of 125 is 5. So our final answer is 5 cube root of 2. Make sure you're very careful about placing this in the notch. If it gets outside, I'm going to think that you are doing 5 cubed times the square root of 2. So make sure, you can even move the 5 out a little bit further to the left. Make sure the index is in the notch, and then it does not drift too far to the left. Example number 4, 4th root of 80. So take a look at your list of 4th powers, right of the equal sign. Which of those numbers, besides 1, because 1 never really gets us anywhere, goes into 80 evenly? I think we're looking for 16. 16 times 5. So the 4th root of 16 times the 4th root of 5. Now remember, it's not square root. 4th root of 16 is 2. So our answer is 2 times the 4th root of 5. Make sure your index is safely in the notch. All right. Go ahead and pause here. Go ahead and simplify the cube root of 270. All right, as we break this up, the cube that we're looking for is 27. So cube root 27 times cube root 10. This is 3, so our answer is 3 times the cube root of 10. All right, now fractions, just a little bit harder. Now if we remember before on square roots, we would break it up, which is a great first step for us here, to break this up. And then we got to fix the denominator. It's a little bit more complicated than it was for square roots. It's not that we're just going to multiply by the denominator. That worked for square roots because essentially multiplying something by itself was squaring, which undid the square root. So what we want to do instead is say, right now I have the cube root of 2. And if I go back and look at my list of cubes, have your list handy. Let's go back real fast. 2 divides into which one of those cubes evenly? So let's go back real quick. Let's look at our list of cubes. 2 evenly divides into 8. That tells us we really want it to be an 8 because we can easily take the cube root of 8 and we won't have a root anymore. So we really want this to be cube root of 8. So we're going to need to multiply top and bottom by what's missing. Since we want it to be cube root of 8, we're going to multiply by cube root of 4, top and bottom. That's going to create on the bottom the cube root of 8. On the top, we just multiply them together. Since they're both in a root, we get the cube root of 28. Now, cube root of 8 is 2. So we'll just simplify there. Our denominator is no longer a root. So we are good. We are done. We don't want to reduce it because that's in a root and this is not, so they don't mix. There's our answer right there. That's it for today. I'll see you next time.